Hello and welcome back to Thailand. This is my coconut grove, and if we look over here, my neighbors with a very loud machine are building some kind of a structure. It can't be a house because it's an odd shape and it's very tall, so I think it must be some kind of a shop or a restaurant or something. Anyway, I've done a really dumb thing. I joined a gym, and when my trainer has me go through the different sets on the machines, I get to rest for 60 seconds between each set. So I need something to help me count to 60. How are we going to do that? Oh, you know how. Okay, so how do I build something that counts to 60? Well, what I want to do is have it on my wrist. I don't have one of those fancy smartwatches, because back in the day, we had watches that went like this, and that's the way we liked it. But today, I'm going to need something that I can build that has a microcontroller, small, dumb, and cheap, some kind of a display, a battery, and I'm going to have to 3D print something to hold it all together, and then maybe a Velcro loop to hold it on. It's not going to be the sexiest thing in the gym, and I'm certainly not, but hey, it's another little mini project to take me away from all the other projects I'm working on. Okay, so I dug into my big old box of I might need this someday parts, and I found some stuff. So I found this is an ESP32 dev module, which is good, and an 8266. Now, I've never gone back and used this style, so I think I'll stick with the ESP32. Now, it's got an onboard voltage regulator, so if I stick something near 5 volts in here, the chip gets what it needs. And I have a choice of these little LiPo cells, which are 3.7 volts-ish. But I really have no way to charge these. So, I mean, I like the form factor a lot this would be quite good with the size of that. But I think I'm going to stick with an 18. No, this is actually a 2170. I should look and see if an 18650 would be a little bit better, because I certainly don't need the raw capacity in this thing. Yeah, I'll go back to an 18650. Because I can charge these, and that'll work out quite nicely. And then in terms of displays, I found two. Both of these are really not viable to be using while you're in a gym. Also, they need a crap load of wires from the microcontroller to the display. That one here and this one here. These are good for, I suppose, in-circuit stationary projects, and I did that one before with the coin counter. But what I ended up finding, and which I just bought and should be here in a few days, is this guy. It's a 1-inch OLED dot addressable display that runs on the I2C bus, which is great because there's only 4 wires: power, ground, clock, and data. So that minimizes the number of wires I have to jumper between is this the one? No, that's the 66. This is the 32. The number of wires is minimized between this dev board and the display. Okay, the parts are here. I already had the ESP32. I had an 18650. I needed to order a single 18650 holder, believe it or not, and I ordered an OLED, and it's so small. Like, it's smaller than my thumb. It's listed as 0.96 inches, I think. And that's the size. So it's going to be like literally that big with a big ass battery underneath it or to the side, I suppose about there. But anyway, proof of concept, quick and dirty. The definition of quick and dirty project. I2C bus, power and ground, and a little software magic. Let's see what we can do. Okay, I'm going to show you the code Just very quick. It's mostly copy and paste from things I found with a quick Google search. One thing you do need to do is import some libraries first. You need the Adafruit SSD1306 library. That's Adafruit SSD1306. You need the Adafruit GFX library, and either explicitly or implicitly through one of these two, you need the Adafruit Bus IO library. I'm using Platform IO right now. Just import it into Arduino or whichever tool you're using, but you do need those. I've also set up my standard board setup for the ESP32 work that I do. Now we'll come over into main. You need these header files, SPI, wire, Adafruit GFX, Adafruit SSD1306. Then, if you want to start choosing different fonts to use on the display, you need to include the corresponding header file. This is a serif 9.7-bit font. This is a mono bold 24.7-bit font, as in 7 bits of ASCII characters. I included them all, and then down below I played around until I found the font that I liked. You define your screen width and height in pixels of the OLED display that you're using, because there's a few variations of them out there. And then this reset pin thing, I just left it alone. You actually initiate the Adafruit library by using this line, Adafruit SSD1306, display, screen width, screen height, the wire that comes from this header file, and your reset pin definition. It's magic, don't worry about it. I also flashed the blinky light on the ESP32 board just for fun, just for another little piece of bling. So I set that output pin. Now, after you create the object for display, you then begin its communication with the I2C address that it's sitting on. And then this is all copy and paste. You spin here waiting for the display to become active. Then, using the display object, you clear the display. Then you can set your font, and you can see I've tried several different fonts, and the one I ended up liking was the free mono bold 24.7-bit. That's good. Then after you've set your font, you get to choose the size of the text you want. And the 24 point in combination with text size 2 fit the OLED display exactly the way I wanted. I want white text, and the code point for choosing the ASCII character set you want to use, straight copy and paste. Okay, this is where the work gets done. I basically drop into a loop that counts from 0 to 60, my seconds limit. When it breaks out of the loop, it comes around, starts counting again at 0, which is very convenient. What I do is I read the state of my light, and then I blink it to the opposite state. But here's where it all comes down to. Every time I come through the loop, I call clear display. I reset my cursor to the pixel X and Y where I want on the screen. Although I think it did come out to be it's actually Y and X. Let's see if set cursor. Now, I think this is backwards because there's no way I'm 60 pixels down from the top, but I am 60 pixels to the right of the left-hand edge. I think this is backwards. Anyway, I use display.println to print the current value of seconds, and it actually prints 30, 35, 42, 60. Works well. And then you call display.display. This actually updates the display with however you've generated everything above, and it sends a static copy of that to the screen. I sleep for 1 second, and then I just go and I display the next second around. It's not going to be too difficult to 3D print a little holder for this. We'll put these two, we'll put them together. The battery holder will go along the bottom. So the whole unit is going to be about that big. So next thing is to design and print a little holder for all that stuff. Oh, I forgot to show you it running solely on 18650 battery power. So that's the entire thing. It's not plugged anymore now that the code is flashed on. Okay, we're out of the breadboard and I've got little jumper wires soldered in the position that they go. Should be able just to drop right into the frame, which is just finished printing. So let's take a look at that. So here's the enclosure done up in Fusion 360. It took me literally 20 minutes to draw this based off the dimensions of where the ESP32 is going to go right here, the OLED display, and the battery. Just basically made those outlines and extruded everything up, made some posts for them to sit on to give some space underneath for the wires and the pins. And these little pins are meant to protrude through the holes and hold the boards in place. And these two slots here are for Velcro straps to hold it onto my arm. I haven't bothered to fillet any of the edges to make everything nice and soft, or made an arm-shaped curve on the bottom here. I think, maybe if I've got another few minutes, I'll make an arm-shaped curve like that, but that makes it more difficult to do a print on the 3D printer. We'll see how that works, but here's version 1. And here's the final result. I actually used these little cap head screws instead of the sticky up pins because they just broke off. Luckily, the 3D printing material, I could just basically screw these little cap head screws down into the posts. And it's all good. Got some Velcro on here. It's a little floopy floppy, but it does the job. And all I have to do is push that button when I end the set, and I rest for 60 seconds. So, not bad for about 4 hours worth of effort. It's a little cyborg, it's a little steampunk, it's a little geek with too much time on his hands. That's the one. Look out, Apple Watch, I'm coming after you. The magic of miniaturization, and I'll take over the market in 60-second countdown wrist straps. Just to give you the complete picture, I need to tell you how much this whole thing cost. So I jumped on to Lazada.com and checked out the prices that I could find for these parts. The ESP board is equivalent of $6.06, which is so cheap for what it provides to you. This chip is a dual core processor with Wi-Fi and memory and input-output controls, and it can do what a $5,000 computer could do 10 years ago. It's ridiculous. The tiny little display is $1.58. The batteries are generic now. You can pick them up for 45 cents. The battery holder is 26 cents. And to print the 3D frame in terms of electricity and the cost of the corn-based plastic, it's 55 cents. So we have a total of $8.90. So for under $10, I just made myself the equivalent of an Apple Watch. And I mean, what else can you say? Hey, if you found this video interesting, please give it a thumbs up. And if you like my other content, I'd appreciate a subscribe. Take care and see you next time.